Okay. All right, so we're back. The puppy is napping, so we have a few minutes to do some math. So I was on a problem, and I think I was making it too difficult. Okay, so this is the problem that we've got here. The diameter is given as 202 feet, which means the radius is half of that. It's 101 feet. And the top of the wheel stands 210 feet above. So this whole thing here is the diameter, which is 202, which means this thing, that little bit right there, is 8 feet. So I'm gonna get rid of some of this because I'm gonna draw like a simpler diagram since we have all the information we need out of this. We need these angles. Okay, so we've got a Ferris wheel, and the Ferris wheel, we draw a line from the center to the ground. This is going to be, so from that point on the ground all the way to the top is 210, and then the diameter is 202. So that means this segment on the bottom here is 8. It's 8. This is 101, so the whole thing is 109. So this whole thing is 109. And then the question basically is asking us, we rotate through some angle here, and then we need to figure out how far off the ground we are at that point. So how far are we off the ground? So we want to find that red line segment, which is h. So what I'm going to do is I'm going to construct two triangles. I'm going to construct two triangles. Actually, I don't even think I need to. I think I can just do it off this. So I'll make a right triangle here by making a vertical line across, and then here we go. So let's see, what do we need? So if this is h here, then that means this side here is also h. And this whole side was 109. So this little bit here is 109 minus h. Then this side is 101 since it's also the radius of this thing. And this angle is theta. So before I think I was doing the most, we can just say from this thing, we can use the cosine of theta is equal to 109 minus h over 101. So we're looking for h, so we'll just solve for that. I'll multiply both sides by 101. And then I'll add h and subtract 101 cosine theta. So h equals 109 minus 101 cosine theta. So I think this is a lot better than what I was doing before, which didn't even work out, so it didn't matter. Okay, so let's see if we get this. So 109 minus 101 cosine of 150. So that one worked. 40, that one worked, and 318, that one worked. Okay, so it looks like we got a good formula here. This will determine the height for all of these angles theta, and I got the same answers here for all three of these, so that one was fine. Okay. let's try another one. I'm going to kind of delete these as I go. This says a soccer field has a rectangular penalty area that measures 136 feet by 53 feet. So penalty area, I don't even know what that is. The goal is 24 feet wide and centered along the back of the penalty area. Okay. Assume the goalkeeper can block a shot 6 feet to either side of their position. For total coverage of 12 feet. The penalty kick is taken from a corner of the penalty area at position A. Goalkeeper stands 6 feet from the goalpost nearest the shooter and can thus block a shot anywhere between the middle of the goal and the nearest goalpost, segment CD. Okay. To score, the shooter must kick the ball within the angle CAE. Okay. Find the measure of this angle to the nearest tenth of a degree. Assume A is 56 and B is 53. All right, so A is 56. And B is 50. So we need to find angle CAE. Okay, so if we take this angle, let's call that theta, and let's call this big angle here different color. Here can be alpha. What can we make? We've got so if this thing is 24, if the goal is 24 feet wide and this is 12, CD is 12, that means EC is also 12. So let's, instead of making that big angle alpha, let's make the angle we're looking for alpha. All right, so now we can say the tangent of theta is equal to 12 plus 56, so that's the opposite, over the adjacent, which is 53. And then we can say the tangent of alpha plus theta, so that's the full angle, is equal to 12 plus 12 plus 56, so 24 plus 56 over 53. And let's see. So what do we got? We've got tangent of theta equal to 68 over 53. And tangent of alpha plus theta equals 70, 80. Okay, so this probably is a good one for the angle sum formula. So let me see if I can remember this. So sine of alpha plus beta would be, or actually let's use alpha plus theta since that's what we have here. sine alpha cosine beta cosine alpha sine beta. Actually, there's probably just one for tangent. Let me just figure it out. Cosine of alpha plus beta equals beta equals cosine alpha cosine beta minus sine alpha sine beta. So you just take the quotient of these. So what would that come out to? Here, rather than, I'm just going to look it up rather than type this all out. There's probably like a really nice formula for this. Let's see. Tangent sum formula. Yeah. Oh, duh. Okay, so it's tangent of alpha plus tangent of theta over 1 minus and alpha tan theta. So this is going to be equal to the tangent of alpha plus theta. And so what do we get? We know this thing, so we can substitute that's 80 over 53. And then we've got tangent alpha, which is what we're looking for, plus the tangent of theta. We've got that. 1 minus 68 over 53 times tangent alpha. Okay, so let's solve. So I'll multiply both sides by that. We're going to get tangent alpha plus 68 over 53 equals 80 over 53 minus, we've got 68. Let's just leave it like that. Okay. And then, so we'll get tangent alpha equals 80 minus 68 is 1253. Got to divide that by 1 plus 80 times 68 53 squared. Okay. Then this 53 squared over 3 squared, and get 12 over 53 cancel 53 over 3 squared plus 80 times 68. Oh no, let's see if that worked. So this is the tangent of alpha. So we'll take the tangent inverse of that. Getting 4.4. Okay, so once you get this tangent of alpha, which is this thing here, you just do second tangent and plug that in, and you'll get 4.4. Okay. Let's do another one. I'm being kind of fast about these because this student has a test today, and I'd like for them to see these worked out. So maybe I should be a little more thorough, but it's tough to do that without like someone there asking you questions. That is the same one, so I don't want to do that. Let's do this one. So the circle in the figure below has a radius of r and a center at C. The distance from A to B is x. Redraw the figure below, label as indicated in the problem, and solve the problem. Okay. So they give us A is equal to 39 degrees, angle A, which is there. And then R is equal to 10. So we want to find x. So we have the opposite and the hypotenuse involved here. So we can say that the sine of angle A is equal to the opposite, which is r over r plus x. And then I'm just going to try and solve for r here. So I'm going to multiply both sides by r plus x. And I'll get r plus x times the sine of A is equal to r. Just got an email, so I'm going to see what that says. Where did this email? Okay. Send this link to my student. Okay. Okay. So then I'll distribute this sine alpha or sine of A to r and x, and I'll get r sine of angle A plus x sine of A equals r, and then let's get our r's on the same side. So we'll get r sine A minus r equals negative x sine A. And then I'll factor out an r. Sine A minus 1 equals negative x sine A. And then divide by sine A minus 1 on both sides. Negative x sine A over sine A minus 1. And then we can just get rid of that negative in the numerator by making this x sine A over 1 minus sine A. I'm just doing that because I don't want to type a bunch of negatives in here if I can help it. Okay, so x is equal to, oh no, we're finding x. So I should read the problem more correctly. So let's go back to here. So I'm going to solve for x. So I'll subtract r sine A from both sides. X sine A equals r, 1 minus, actually we'll just do r minus r sine A. So I subtracted r sine A from both sides, and then let me divide by sine A. So x equals r minus r sine A over sine A. All right, there we go. So r is 10 and A is 39. So we've got 10 minus 10 times the sine of 39 divided by the sine of 39. And I got 6, rounding to the nearest whole number, obviously. So you could have chosen to like substitute in 10 and 39 on this first step here, but you know, that's a lot more writing, so, or I guess it's not a lot more, but it's enough to make me not want to do it. Okay. So let's do another one. And I guess like I pretty inconsistently decided whether or not I was going to put the problem numbers in here. Anyone who's coming along later and finding this can know which problem it's for. I should make it searchable, but I'm too lazy. Okay, simplify the expression root x squared plus 1 as much as possible after substituting tangent of theta for x. Okay, so this is actually a really interesting question. Let's make like okay. Oh, that's terrible. All right, so suppose you have a right triangle and you have this angle alpha, and you know that the tangent of, this angle theta, you know that the tangent of theta is equal to x, which, you know, x is equal to x over 1. So you know that this is x, and so the tangent is the opposite over the adjacent, and this is 1, which makes this 1 squared plus x squared, or just 1 plus x squared. So if you take this and you substitute in the square root of, let's see, this is going to be tangent squared. Oh, actually, this is even, we don't even need all this. We just use a Pythagorean identity. So we can start from here. Cosine squared plus sine squared equals 1. And then to make a tangent out of this, I've got to divide both sides by cosine. So cosine squared, sine squared, and cosine squared. And then what you get is 1 plus tangent squared theta equals the secant squared theta. Okay, so let's hold on to this for a moment. So going back to this here, we are taking this x squared plus 1 square rooted, and we're substituting in tangent theta for x. So this is tan squared theta plus 1 square rooted. But you can see here, 1 plus tangent squared theta is actually equal to tan squared theta plus 1. That's just the commutative property. And so I can substitute this in for here, making this equal to the square root of secant squared of theta, which is just secant theta. So, you know, they're saying substitute this as much as possible. I don't, or simplify it as much as possible. I don't know if this is like simple or exactly. It's an identity. Yeah, this is what they mean though. Oh, we got 2 people watching now. Wild. Y'all missed the puppy. It looks like he's gonna start crying again, so maybe he didn't miss the puppy. Okay, so we've done that one. Let's get this open. Okay, so this is going to be a similar thing, kind of working with trig identities and maybe some Pythagorean identity again. So it says multiply and then simplify your answer completely. So this is a difference of two squares. And you should be looking for these things. Everyone will recall from Algebra 2 when you have this special product here, a minus b times a plus b. This is called the difference of two squared. So if you FOIL this together, you're going to get a squared plus ab minus ab minus b squared. And these two cancel each other out. So you get a squared minus b squared. And so this is a, and this is b, and this is a, and this is b. So we just make this 1 minus sine squared of theta. So put a pin in that for a second. Then go back to your Pythagorean identity. So this thing is always true. That's why it's an identity. And I can make this thing out of that. I'll just subtract sine squared from both sides. And I'll find out that cosine squared of theta is equal to 1 minus the sine squared theta. And so that's how you're able to see this. So this is 1 minus sine squared, this is 1 minus sine squared, and so we get cosine squared of theta. So not too bad. Let's get rid of that. And okay. So another one of these kind of identity problems. Okay, so this says add or subtract as indicated. Then simplify your answer if possible. Leave your answer in terms of sine of theta and or cosine theta. So let's start with what they give us here. They give us this sine theta plus 1 over cosine theta. And so how do we add fractions? We need a common denominator. So here we've got a denominator of cosine. So I'm going to give this one a denominator of cosine. The way I do that is I multiply by cosine of theta. Oh, oops. Mistake here. Just that. Cosine of theta over cosine of theta. Cosine of theta divided by cosine of theta is 1, and you can just always multiply by 1. So now this is sine theta, cosine theta, or cosine theta sine theta, plus 1 over cosine theta. And, you know, I get the same kind of confusion with students when I have to, like algebra students, when I have to ask them to add something like this, right? They're like, how do I add that? Well, you know, how do you add fractions? You just add the numerators and leave the denominator the same. It's x plus 1 over 4. And it seems like kind of pointless to ask that. And it is really, like, there's no reason why you would need to do it if it made sense in the moment, but like to test you on it, we're just like testing you on it to see if you have that skill. So if I ask you to add these two together, like, what do you mean? You can't add them together. Like, I don't know what x is. It's the same thing with this. This thing is equal to this thing. You know, you haven't actually changed it. So if you're confused, that's, you know, maybe the reason why. Okay, so that first one was rough because I did it in a terrible long way. And then when I redid the diagram, it seemed much easier. it's on that. Oh goodness. Okay, so I'm not going to shrink this down anymore. Write the following in terms of sine and cosine, and then simplify. Okay, so that's like really clear instructions. Write it in terms of sine and cosine and simplify. So we have the cosecant of theta minus cotangent of theta times the cosine of theta. And so we want to write this in terms of sine and cosine, which means use your reciprocal and quotient identities here and here. So cosecant is the 1 over the sine. And then cotangent is cosine of theta over sine of theta times cosine of theta. And so it looks like we've got a common denominator here. So this is actually going to be 1 minus cosine squared. So these two multiply together to be cosine squared all over sine of theta. We have a common denominator there. And 1 minus cosine squared is equal to sine squared. And one of these signs will cancel out. Something that was really confusing for me the first time I saw this notation of this like sine squared was I didn't know what that meant, because it was like it was by the sine, it was not by the theta. This is really sine of theta times sine of theta. So you just have, two of these, and then you cancel a pair, like one from the numerator, one from the denominator, and you get sine of theta. Actually, oops. All right, that's the one we just did, so we're gonna put this one over. Okay, so write the following in terms of cosine only. So we want to get this in terms of cosine only. So we've got the cosecant of theta. So this thing is equal to 1 over the sine of theta. And then, so what we can do is, let's use our Pythagorean identity. So kind of like as an aside here, I'm going to say cosine squared of theta plus sine squared of theta equals 1. And I'm basically trying to find sine of theta. So let me solve for sine squared. So I'm going to subtract cosine squared from both sides. And then we'll take the square root of both sides. So sine of theta equals plus or minus the square root of 1 minus cosine squared of theta. And then when you're doing this on WebAssign, you can see this plus or minus. That's a huge clue as to where you're supposed to go. If there's a plus or minus, there's a square root involved. And so this is sine, this is sine. I'm going to make a substitution, which means this is equal to 1 over plus or minus square root of 1 minus cosine squared of theta. And then we can just bring the plus or minus out front, which is how they have it. And so you wouldn't type this in, you would just type this portion in, since they already have the plus or minus outside here. Okay. And like, how are you supposed to know to do that? See enough of these, you just, so like here's another example. So if you saw something like this and the directions say write the following in terms of sine only. So you only want sine of theta in this expression, and like, numbers. So if you see this cotangent and you know that, you're like, oh, I've seen the similar problem just on the last one. So you start off. Okay. So I don't know how long I was crashed for. Let me see what we got here. Let me go back for a little bit. So we're just going to do the same thing that we did last time, essentially. I know that I only want signs of theta in there and like numbers. So start by writing your problem, and then you're just going to make like substitutions and multiply by 1. That's the strategy. So cotangent, this is cotangent. Cotangent of theta is cosine of theta over the sine of theta. And then we can make that same trick as last time. So so the good thing is only OBS crashed this time and not my entire computer. Let's do the same thing. So as an aside over here, let's bring up the Pythagorean theorem, or the Pythagorean identity. And then I want to make a substitution for this cosine to get it to sine. So I'm going to subtract sine squared from both sides. And then take the square root. Cosine of theta is plus or minus the square root of 1 minus sine squared of theta. And then since I have cosine here and cosine here, I can make a substitution. I can bring this over. So then this is going to be equal to plus or minus the square root of 1 minus sine squared over sine. And you've got this here, so again, don't type that when you enter your answer. Oh no, don't crash. Okay, so we got that. Let's do another one. Okay, so these ones are like really nice problems. They're just super quick hitters and easy. So find the remaining trigonometric ratios of theta based on the given information. So they're going to give you enough information to figure out one of the trig ratios and what quadrant you're in. So they might tell you like theta is on the interval from 0 to pi over 2. Or actually, they wouldn't include the endpoint, so this would be like this. They'll tell you that it's in a quadrant in some way. Like they'll give it to you this way, or they'll just say it's in quadrant 3. So what you do is you draw an angle in quadrant 3. It doesn't need to be to scale or anything. And then you use that and construct a triangle here. Okay, so you know that the sine of theta is the y divided by the hypotenuse. So that means y here is -1, and the hypotenuse is, so this is the point, -1. And we just need to figure out what cosine is. The hypotenuse is 2. So this is y over r. Then you can use the Pythagorean theorem to figure out this side x here. So x is going to be equal to 2 squared minus 1 squared, which is 3 square rooted. Actually, let me do that out. So we'll say -1 squared plus 2 squared equals x squared, and then plus x squared equals 2 squared. And then we can subtract. So we get 4 minus 1, and x equals plus or minus root 3. And so you can actually look and see, okay, this is in the 3rd quadrant, so I know I have to take the minus. X is negative in the 3rd quadrant. So this is -√3. Root 3. Oh, did I do this backwards? This point is backwards. It's -√3 and -1. Yeah, so xy. That's a really common mistake that I always catch my students making, and I can't believe I did that. Okay, so now you have it. You really didn't need to do all this. If you know your unit circle pretty well, you would know that this negative 1/2 goes with negative √3/2. But it's the same process if they give you a different ratio, like if they give you like 7/8 or something like that. It's very similar. So I guess it's good to go through this. Then with this information, you have theta here. You just, and this is x, this is y, this is r. You just go by the definitions. Cosine of theta equals x/r, which is negative √3/2. Oh, I misread this. This is not in quadrant 3. So sine is negative, but it's not in quadrant 3. So where else could sine be negative? Since sine is the y, it goes in quadrant 4. Okay. So same process here. Y is -1, hypotenuse is 2. So now we have the positive x since it's in quadrant 4. Okay, so then we've got cosine of theta equals √3/2, the x/r. We did sine already, that's what they gave us. So we'll do tangent of theta equals y/x, which is -1/√3. And we want to rationalize this, so we'll multiply by √3/√3. To rationalize the denominator, we get -√3 divided by 3. Then we can do cotangent of theta, which is equal to the reciprocal. Now, a lot of people will try to do the reciprocal of this one, and then they have to rationalize it. So let's just do the reciprocal of this one. It's going to be √3/-1, which is -√3. And then the secant of theta is 1 over the cosine, so it's the reciprocal of the cosine, which is r/x, which is going to be 2/√3. So we'll rationalize that. It's 2√3/√3, and the cosecant is 1 over the sine. So where do we have the sine? The sine is here, so the reciprocal of -1/2 is -2. So not too bad. Let me just check my email. Okay. This is, not important. Okay.
Get duck.
Okay. The puppy is learning words. I don't know if you know this, but he's going to be a YouTube star. He was on YouTube a few minutes ago. Although I think I deleted the video because I didn't actually answer the question. All right, so find cosecant of theta if cotangent is this. Okay, so cotangent is negative. They give us a negative number here, and then they tell us that sine is positive. So if sine is positive, but cotangent is negative, that means cosine has to be negative. So where is cosine negative and sine positive? That is in the third quadrant. So we've got an angle in the third quadrant. And cotangent is the x over the y. That means this point here is going to be -20 over 21. And so we can do 20 squared plus 21 squared equals the radius squared. So what does r equal? This is 400 plus this would be 400. Yeah, I think. which is 881. And let's see. Let's do 20 squared plus 21 squared, 41. I can't add. So this is 841. And I'm going to remember to take the square root of that, which is 29. Okay, so that means R is 29. So then you just, to get the cosecant, it's the reciprocal of the sine. So it's R over Y, which is equal to 29 over 21, which is what we've got here. Okay. Let's do another.
Get duck. Get duck. Good job. Good job. Good job. Duck. Get duck. Get duck. Yeah. Get duck.
Use the equivalent forms of the first Pythagorean identity. If sine of theta is equal to -4/5 and theta terminates in quadrant 3, find cosine. So we know that we're given the sine, and we're told that this terminates in quadrant 4, 3. So sine is negative, cosine is also negative here. Sine is the y over the x, or I'm sorry, the y over the r. So we know that y equals -4, r equals 5, and so we can use the Pythagorean identity in order to, or the Pythagorean theorem in order to find this other side, which we know is negative, but we also know this is a 3, 4, 5 triangle, so it kind of shortcuts it. And we want to find the cosine, which is the x over the r. So cosine of theta equals -3 over 5. That one.
Oh no. Oh. Here.
Done. Oh.
No.
Oops. Yeah, I didn't want to do that. Save. I opened it. That's okay.
Let go. Let go.
So this is let sine of theta equal -4/5 and cosine equal -3/5. Find the indicated value. Okay. So we've got sine and cosine both negative, and when sine and cosine are both negative, that means we're in the third quadrant. And sine is the y over the r, and cosine is the x over the r. So that's how we find those sides. And we need to find the secant. The secant is the reciprocal of cosine, so we just secant of theta equals r over x, which is -5 over 3. And you can really just see that here. Not super hard. What do we got here? So indicate two quadrants theta could terminate in given given the value of the trigonometric function. So cosine's negative. Where is cosine negative? So cosine equals x over r. Now r is always going to be a positive number since it's a radius. That's just a length. So we really only need to consider, like, is x negative or positive? So if cosine is a negative number, that means x is negative. Which quadrants is x negative? This comes from, like, not some kind of trig thing that you need to memorize. It's just how points are plotted on the rectangular coordinate plane. This is the positive side of the x-axis, and this is the negative side of the x-axis. So that means over here in quadrants 2 and 3. Yeah, so just a little quick hitter. And those are like gimme points, you know, just get all of those. Same thing, so indicate two quadrants theta could terminate in given the value of the trigonometric function. So here we see that sine is positive. Well, sine is y over r. And r is just always a positive number because it's a length. So where's y positive? Y is positive in the first and the second quadrants. And again, this is not like trig knowledge. This is just, you know, from your algebra days. Where's y positive? Y is positive up here. Y is negative down here. So these are the two quadrants where y is positive, and that's quadrant 1 and quadrant 2. And let's see. Is that what we just did? That's what we just did. Why are you yelling at me? Stop it. Stop it. Stop it. YouTube doesn't want to hear me. Okay. I guess the puppy says that's it.